Assalamualaikum everyone. In this video, I'll be discussing 5 questions of circular motion. Are you ready? Let's go. Question number 1. A motorcycle has a constant speed of 25 meters per second as it passes over the top of a hill whose radius of curvature is 150 meters. So you see here that the radius of curvature, it is a partial of a big circle. Alright, so we do the listing, the velocity, the radius, and the mass like this. And then let's take a look at question A. It's asking for the centripetal force, so Fc. So Fc, we know that the equation for Fc equals to mv squared over r. So we do the substitution, all the values, the mass, the velocity, and the radius. And the final answer is 1541.7 Newton. Right, let's go to question B. It's asking for the normal force. So let's do the FBD. Normal going up, weight going down. So here the weight is a centripetal force. Why? It's because the curvature is a fraction of a very big circle. Hence, it's the weight that becomes the centripetal force. So the weight is positive and the normal force is negative like this. So W minus N equals to 1541.7. So we shift the weight to the other side, to the right side, and we substitute all the values like this. So your final answer is 2088 Newton. Let's go to question number 2. A Ferris wheel in an amusement park has a radius of 8 meters, making one rotation in 18 seconds. So one rotation is actually 2 pi. So it's out, oh my goodness, it's out of the frame, sorry. And the 18 second is the time. So what I'm doing here, now I'm trying to find the angular frequency, omega. So omega equals to theta over time. So the theta is 2 pi here because 2 pi is the radian. So 2 pi over 8 equals to 0.35 radian per second. And then from here, I'm going to find the velocity, the tangential velocity. The equation is V equals to R omega, the R which is 8 meters, and the omega, the one that we just got, 0.38. Hence, the velocity is 2.79 meters per second. Alright, so the Ferris wheel, we have the highest point and the lowest point. So I'm doing here, we have weight going down. This is at the top, okay? At the highest point. And then at the bottom point, again, they are the same. Normal force going up because we have the surface of we have the rail, right? So see, they are the same. But the position at A is the highest point, while at B here is the lowest point. So let's see, what should we do? So for question A, we have to draw the free body diagram at the highest point. Normal going up, weight going down. But now we have to determine which one is the centripetal force. So here I put the weight because it's the weight that going to the center of the motion. So here everything going to the center. You see here that the weight is the one that becomes the Fc. So weight becomes positive. So W minus normal equals to mv squared over r. Here we're trying to find the normal force, right? So we change the position of the weight to the right side of the equation. We do the substitution. And your final answer is 309 Newton. Let's go to question number B. We are trying to find the normal force at the lowest position. Now this time, it is the normal that becomes the centripetal force. So the normal becomes positive. So normal minus weight. So let's do Fc equals to mv squared over r, normal minus weight equals to mv squared over r. And then we change the position of the weight to the right side of the equation like this. And your final answer is 377 Newton. Let's go to question number 3. A roller coaster at an amusement park has a dip in a vertical circle of radius 20 meters. A passenger feels the seat of the car pushing upwards on her with a force equals to 1.5 of her weight as she goes through the dip. How fast the roller coaster travels at the tip of the roller coaster line. So we have the radius 20 meters, and here it says that the upwards on a force is equal to 1.5 of her weight. So it is 3/2 of her weight. So we have here, this is the roller coaster going at the dip, which is at the lowest point of the circle. So we can see that definitely the normal force is the centripetal force. So the normal force becomes the positive. So N minus W equals to mv squared over R. We substitute the normal force, which is 3/2 of the weight, and then the weight I straight away substituted with mg. So minus mg equals to mv squared over r. This one we just copied it down, and look, we can cancel out all the m's. And then we rearrange the equation, and we got 0.5 gr. So our velocity is 9.9 meter per second at the dip, which is at the lowest point of the roller coaster. That's all. Question number 4. How large must the coefficient of static friction between the tires and the road if a car is to turn around a level curve of radius 25 meters at a speed of 92 km per hour? So I do the listing. Mu s is the one that we want to find, and the r is 85 meters. For the velocity, it is 92 kilometers per hour, so we have to change it into meter per second. So 92 times 10 to the power of 3 over 1 hour is equivalent to 3,600 seconds. And our answer is 25.5 meter per second. So this is like the sketching of a car, and we want to make a curve. A level curve is like a straight curve, like a horizontal curve. So it curves to the left. So I want to zoom in here. So this is the big tire. So I'm zooming in the tire, and this is the rough surface of the road. So in order to determine the direction of the friction force, we have to imagine what happens if the road is slippery to the point that there is no friction. Here the car will skid to the right. Hence, the friction is to the left, or specifically, it's in the direction towards the center of the circular motions. Hence, the friction is the centripetal force. So we're doing the FBD right here, normal going up, weight going down, and the friction going to the left. So FC equals to mv squared over r. We don't have any other force along the horizontal. So Fs equals to mv squared over r, where the Fs is mu Sn, which is mv squared over r. We just copied it down. And here, along the y-axis, it is 0, because there is no acceleration whatsoever along the y-axis. So n equals to mg. The normal, I shift it to the right and change it to be mg. So I do the substitution straight away, and we get the answer of the coefficient of static friction, which is 0.78. Let's go to the last question. Captain Azza wants to practice vertical circles for her jet flying exhibition. If the speed of the jet is 78 meters per second at the bottom of the circle, what must the minimum radius of the circle to be? Ensure that her acceleration at the bottom does not exceed 3g. So the velocity is 78 meters per second. I do the listing over here. So in order for not exceeding the acceleration of 3g, which is a equals to 3g, I put it here like this. This is our circle motion, yeah? So this is the jet, and we want to whoop, because it's curving up like that. We do the free body diagram. This is the weight, and this is the reaction force. I initially put it normal force, but then again, because we don't have any surface, right? So this is actually a reaction force and not the normal force. So AC, because we want to find the radius, the maximum radius, we just use AC. AC is a centripetal force, and the equation is V squared over R. So 3G, we just put it back in the 3G. We do the substitution, 78 squared over R, and the R is 206.73 meters. Question B, what is her apparent weight. So what is the reaction force? What is the value of the reaction force? So the reaction force in this case is the centripetal force. So the R is positive lah. So R minus W equals to MA. You shift it to the right of the equation. And then the acceleration is 3g. So the answer is 4gm. So the gm is actually the weight. Mg means that her apparent weight is actually 4 times her original or her real weight. That's how we know. That's all. Thank you, everyone.